Assalamualaikum warahmatullahi wabarakatuh. I am 2180081 Muhammad Ramadan Zulkifli, and today I would like to present my poster about performance of concrete beam retrofit using fabric waste. Okay, first let's go to introduction. Concrete is the material that widely used in the construction field, which is we can see the column concrete, the concrete beam, and also concrete also used in foundation and in building bridge. Next is, as we know, concrete is strong and we can find it easily, but however in their service life, the concrete itself need for modification or improvement to keep their performance. And then in Malaysia, we know there are many fabric waste in Malaysia, and the fabric waste also being a factor that keep increasing the number of waste in Malaysia. And if we can use this fabric waste as a one material in construction, it will be one of the big step to reduce the fabric waste in Malaysia. Number 2, we go to problem statement. So first one, to study the strategy for strengthening concrete structure using a combination of waste material from fabric and also epoxy as the adhesive material. And the second one is concrete structure are in need of modification and improvement in their service life. And then for number 3, we go to objective of the study. For the first one is to determine the strength of concrete beam reinforced using waste with composite textile material. Second, to determine the tensile strength of fabric waste composite. And number 3 is to determine the optimal configuration for concrete beam. And then let's move to methodology. Number 1 is concrete mix design. The concrete mix design that be used in this study is concrete with grade 30. To achieve grade 30 concrete, we must use the ratio 1:1:2, which is 1 cement, 1 sand, and 2 aggregate. So the next one is preparation of concrete beam and fabric sample. So for the concrete beam sample, we use a mold that is sizing 500 mm times 100 mm and 100 mm height. Then for this fabric sample, we use a carton type of fabric and we layer it with epoxy for 1 layer, 2 layer of fabric with epoxy and 3 layer of fabric with epoxy. And then we will proceed to tensile test on the fabric sample. Then after complete the tensile test of the fabric sample, the chosen type of fabric with the chosen layer, we use the fabric to strengthening the concrete beam sample. For method to strengthening this concrete beam sample, we use 3 type of wrapping, which is full wrapping, diagonal wrapping, and mesh wrapping. After complete wrapping all the concrete beam sample, then we will proceed to flexural strength test to determine the flexural strength for each sample that we wrap. Then after complete the flexural strength test, then we will go for data collection and analysis of the result. So let's proceed for the result. For tensile test result, we can see we have test 3 different layer of fabric, which is 1 layer with epoxy, 2 layer fabric of with epoxy, and 3 layer of fabric with epoxy. And the tensile strength for the 1 layer of fabric with epoxy is 0.086 kilonewton, and the tensile strength for 2 layer of fabric is 0.14 kilonewton, and for the 3 layer of fabric with epoxy, the tensile strength is 0.19 kilonewton. So we can see the tensile strength for 3 layer of fabric with epoxy is the highest than the 1 layer and 2 layer of fabric with epoxy. Then for strengthening the concrete beam, we will use the 3 layer of fabric with epoxy to strengthening the concrete beam sample. Then we will proceed with the result for the flexural strength test. So for the control sample, the flexural strength is 6.96 megapascal. For full wrap sample is 5.83 megapascal. For the diagonal wrap is 4.86 megapascal, and for mesh wrapping is 6.26 megapascal. And we can observe that the control sample has the highest flexural strength among the wrapping sample. And then we can observe also the mesh wrapping type of sample has the highest value if we compare it to the full wrapping and diagonal wrap sample. And then we go to conclusion and recommendation. Now the first one is the wrap sample strength is lower than the control sample is because from the lack of bond between the fabric, the epoxy and the concrete beam itself. So this conclusion can be observed from the fabric sample after complete the tensile test, because we can see the fabric with that layer with epoxy are not separate completely, and as we can observe, the layer of the separation is the layer with epoxy, and the layer that still stick together is in high percentage of the fabric only. So the second one is the failure pattern of mesh wrap sample is only crack appear underneath and on the side of the beam and not separate into two like the contour sample and full wrap sample, and also the diagonal wrap sample. And for recommendation, this study should be done with the different type of epoxy, so we can see the behavior of the concrete beam or the fabric waste itself after we layer it with different type of epoxy. That's all from me. Thank you for watching.